Hello once again! For this new lecture together, we will focus on alternative fuels and especially biofuels. In the first part, we will see why biofuels can be interesting and what the main families of biofuels are. The second part will focus on the biofuels specific to spark ignition engines. And the third part will be on diesel biofuels. To finish, we will propose you an interview with Pierre Porot, who is in charge of R&D project on biofuels at AFP and Énergie Nouvelle. During the first week, your professor presented the drivers of the transportation industry. The main challenges are, first, the reduction of pollutions, including greenhouse gas emissions, such as CO2 emissions, and the reduction of local pollutants, such as CO, HC, NOx particles. The reduction of the energetic dependency on petroleum products is another challenge. And finally, the transportation industry needs to find a solution in acceptable economic conditions. So, biofuels appear to be a good answer. In 2010, biofuels represented about 3% of the worldwide energy consumption in the automotive transport. In the future, several scenarios are proposed, going from 5% to 15% in 2025. In Europe, 10% of energy for the transport sector should be renewable in 2020. In order to measure the impact of biofuels on greenhouse gas emissions, we can calculate the well-to-wheel balance. This means, first, we measure all the greenhouse gas emitted by the production of the fuel. This is called the well-to-tank balance. Each step of the fuel production is taken into account: extraction of the crude oil, its transport, refining, transport of the fuel, supply at the pump. Then the tank-to-wheel balance is added. This last step considers the greenhouse gases emitted by the vehicle that burns this fuel. In the case of biofuels, we can have significant emission savings at the source because emissions of CO2 are captured by the vegetation during its growth. Greenhouse gas emissions are therefore lower for biofuels. In Europe, since 2009, to be a real biofuel, the biofuel should generate more than 35% of greenhouse gas emission savings compared to a fossil fuel. And in 2017, this saving should be higher than 50% and higher than 60% for new plants. Now, let's focus on the biofuel families. What are they? There are three generations of biofuel. The first one comes from agriculture, and in that case, there is a competition with production for food. For spark ignition engines, the main biofuels are ethanol and ETBE, the ethyl terbibutyl ether. Ethanol is produced from wheat, corn, sugar beets, or sugarcane. For diesel engines, the first generation of biofuels is called FAME for fatty acid methyl esters. They are also called biodiesel. They are produced from rapeseed, soya, sunflower, or palm. The second generation of biofuels is produced from lignocellulosic resources. It means we use farm wood or waste wood. There is no competition with food usage. Nevertheless, large areas could be used for their growth, and it could lead to a risk for biodiversity. For spark ignition engines, the biofuel remains the same, ethanol. Only the raw material and a part of the process change. For diesel engines, this second generation of biofuel is called BTL for biomass to liquid. Finally, the third generations come from algae, which are not in competition with food, and they require low available area. Yield can be higher than for first and second generations, but process chains are not economically viable yet. During this first part about biofuels, I have introduced an important concept, the well-to-wheel balance. The last part of the serious game will focus on that. So, do not hesitate to watch this video again, and if you have any questions, contact me on the forum.